No issues? No issues, huh? Okay, so if that's the case, then I'll move on, yeah? Okay. Yeah. Sorry? 5B. 8D. 5D, huh? Okay, let's look at 5D then. Come in. Come in. Come in. Okay, so we have y equals to cosine x plus 1 over x minus 1. Okay, so if I want to differentiate this, alright, cosine when we differentiate it becomes negative sign. Okay, then what is the angle that's going to accompany this function itself? It will remain the same, x plus 1 over x minus 1. Okay, so that's the very first thing that we have to cover when we actually differentiate. We tackle the Trigo function first. Okay, then we proceed inside, okay, towards the angle. Right, we see that the angle is x plus 1 over x minus 1. And that's where we need to apply our quotient rule to differentiate this thing itself. So applying quotient rule to differentiate this, we differentiate the we keep the bottom, differentiate the top, minus away, keep the top, differentiate the bottom over x minus 1 squared. Okay, so this part itself is the differentiation of the angle inside. Okay, then after that we try to simplify it, so we get negative sign x plus 1 over x minus 1. In this case, x minus 1 minus x minus 1. We get this, right? Questions? Okay. So we have practiced our skills in terms of differentiating our Trigo functions already. So we learned how to differentiate our sine, which becomes cosine. Differentiate cosine becomes a negative sign. And differentiate tangent becomes your secant square. Okay? So just plug it over here. Okay, today I want to touch on certain problem sum kind of questions, okay, that makes use of our tangent normals, okay, rate of change, maximum, minima, and all that, yes. For what? That one is it to be confirmed, yeah, because 15.1 homework not due today, because I want to finish out this whole thing. Because some of the questions, I haven't touched upon it, right? Because I think I mentioned 7, 10, 13, 16 are problem sums that you may not have known. If you already know how to do, sorry very loud, okay. If you know how to do it, okay, then that's good. Okay, if you have already completed, then that's good, right? But let me finish up try 4 and question 15 first. Okay. So it says that a curve has an equation y equals to cosine x minus 2 sine x. Okay, we want to find the value of x whereby x is between 0 and pi. It is found in radians. Okay, so our calculator needs to be in radian mode, for which the curve has a stationary point. Okay, so stationary point means that our first derivative has to be equals to 0. Okay, it could either be a minimum point, maximum point, or even point of inflection. Alright, so let us first differentiate the equation of the curve that we have. cosine, we will get our negative sine x. Minus 2, differentiate the sine, we get our cosine x. So the first derivative is negative sine x minus 2 cosine x. Right? Stationary point, the derivative is equal to 0. So we put that out first. Okay. So negative sine x minus 2 cosine x is equal to 0. And we want to find the value of x. This is where your Trigo skills need to come back in. Okay. So how to solve a Trigo equation? What must we do first? Divide by cosine. Okay, so everybody suggests divide the whole thing by cosine. So that means also to say that every single term we divide by cosine, we end up having a negative tangent x minus 2 equals to 0. The whole purpose of dividing by cosine is so that, okay, we can get a single Trigo function. Okay, you must always arrive at a single Trigo function, then we can go about solving a Trigo equation. Okay, then we shift things around, we see that tangent x is equal to negative 2. Okay, then what next? What next? Yep. ASTC, okay. What can we get from an ASTC? S and C. Because this is a negative, so rely on ASTC, we see that the angle x must be second quadrant or fourth quadrant. After identifying quadrant, what do we need to do next? Okay? Yeah, but I'm talking in general first. Okay? So, in general, when we want to tackle it without taking the fact that our x is between 0 and pi, we will see that the angle x must be in the second quadrant or the fourth quadrant. Okay? Then after that, because the condition given the question is that it's between 0 and pi, therefore we only take the second quadrant angle. Okay? But I'm trying to make use of this question to revise your Trigo skills also. Alright, so therefore, after you do this already, we must find the basic angle. And basic angle is by taking the inverse of the function, okay, inverse of the value, alright, the positive value of negative 2. So you must take tangent inverse of 2. Okay, then after that, key that into your calculator, we would get 1.1071. This is in radians. Okay, and x is equals to your second quadrant angle, so that would be pi minus 1.1071. So second quadrant angle will be 2.03. If you go and proceed to find the fourth quadrant angle, we have 5.18, which we need to reject because it is out of the interval of 0 to pi. Because angle is in radian, here answer should be in 3SF. Questions? Next, part 2. Okay, we have answered the question now. So x equals 2.03 gives us our stationary point. Okay, we want to determine the nature of the stationary point. So sorry, can you repeat again? you will not be penalized if you did not write this part. Yeah, but I want to actually make sure we can revise our Trigo along the way lah. Yeah. Okay, then okay, so how was it? Is the nature of stationary point. Okay, part 2, determine the nature of this stationary point. Alright, you can either use your first derivative test or second derivative test. Okay, so depending on the question itself, okay, sometimes you may find that what you have is a bit complicated to differentiate another time. Okay, so you may not want to go and do your second derivative test. Okay, but in this particular case, having negative sin x minus 2 cosine x, it should not be difficult for us to differentiate again. Alright, so doing a second derivative test might be more efficient. Okay, so differentiating your negative sin x, we will get negative cosine x because sine becomes cosine. While differentiating your cosine x, I will get a negative sin x. So we are saying that second derivative is negative cosine x plus 2 sin x. We want to determine the nature at the point where x is equals to 2.03. So when x is equals to 2.0344, key this into your calculator and determine the value. Must be in radian mode. Very often when doing your calculus, okay, your differentiation integration using trigonometry, we are often in radian mode. So in this case we get 2.2360, which is more than 0, and that will tell us that the stationary point is minimum or maximum. What would it be, Joseph? Minimum or maximum? Minimum. Minimum, okay, great. Questions? Okay. I anyway survey the center part. Now we look at exercise 15.1, question 15. We have a function sin x plus cosine x. We want to find the coordinates of all the turning points. Okay, so all the turning points meaning to say that your first derivative must be equals to 0. So we first find out what is the first derivative. What would the first derivative be equals to? Answer? Cosine x. Say again. Minus sin x. Great. So this must be equals to 0. How to solve? Joseph, use your brain so that it stops sleeping. Divided by cosine, so we divide throughout by cosine, we will get 1 minus tangent x equals to 0. Right? Bring tangent over. Tangent x equals to 1. Basic angle is equals to? What would the basic angle be? Joseph? Say? Did you say something? What would the basic angle be? Oops. I want the rest of you go and figure it out also.
45.
Sorry? 45? Are we supposed to do it in degrees? Then?
Pi over 4.
Pi over 4. Why not 0.78539? Tangent inverse 1 what? Isn't this how we find basic angle? Right? So best calculator, it says 0.78539. The rest of you follow, right? How I get 0.78539. So why not I put it this way? Will you do it this way, or you would just put pi over 4? Or there's nothing wrong at all with both? What do you think, Joseph? You put pi over 4. Alia, what will you put? What will you put? Sorry? Pi over 4. Will everyone put pi over 4? So Chen, you will put this? Okay. Right. So I want to address, okay, in this case, you need to recognize that this value generates for you a special angle. Okay. Tangent x equals to 1 is only when the x itself is 45 degrees or any other cycles of it. Okay. So the basic angle itself, okay, will be 45 degrees. But since you're talking about radian, you need to recognize that it should be pi over 4. Okay. If we can put it in exact, we put it in exact. Right? So do remember your special angle values. Okay? So it is helpful if you actually key it inside your calculator in degree mode first. Because in degree mode, surely when you do inverse, they will give you your 30, 45 or 60 very clearly. But if you key in your radian mode, okay, it will give you your wrong decimal. It will never show you pi over 4. Okay, so if you do it in degree, you realize that it is actually in your special angles, then you do your radian conversion on your own. Okay, pi is 180 degrees, so 45 degrees will be 180 degrees divided by 4, which is pi over 4. Okay, so we found the basic angle already. Going back to the question, we want to find the coordinates of the turning point, which is the value of x. Okay, so falling back on our ASTC, tangent x is positive, first quadrant and second quadrant. Okay, so first quadrant angle will surely be the basic angle. Third quadrant angle will be your pi minus pi over 4. Does anyone have problems recalling how to identify the angles using your basic angle? Yeah. It's sorry, pi plus pi over 4. Sorry? No, not x only. X and fx. I haven't finished yet. Yeah. So you need to find the x value, then you can find the fx value. Okay? So, sorry, this one pi plus pi over 4. If you have any issues in terms of the, knowing what is the angle out of your quadrant, please come and look for me after school. Okay, so x is equals to pi over 4 or pi plus pi over 4, which is 5 pi over 4. We want to find the coordinates, so x coordinate we got it already. We need to know the y coordinate as well. So, when x is equals to pi over 4, your fx would be this. Keying that into your calculator, you would get a square root 2. Clearly your calculator will not give you insert form. How I know that square root 2 is because sine 45 degrees is root 2 over 2, cosine pi over 4 or cosine 45 degrees is root 2 over 2. So adding that 2 halves up, we get 1 whole of square root 2. Then we do the same for 5 pi over 4. So sine 5 pi over 4, right? Okay, because it is a third quadrant angle, okay, your sine and your cosine will be negative. Okay, so negative of what? Negative of your sine pi over 4. So sine 5 pi over 4 is negative root 2 over 2, and cosine 5 pi over 4 is negative root 2 over 2 as well. So we get negative root 2. In this question, they did not ask for you to determine the nature of this turning point. So you need not go and find out whether is it a maximum or minimum. Right? But then again, how are we so sure that these points are turning points? What is considered turning points? It must be maximum or minimum, right? But if we look back at the process that we have done, where we let the first derivative to be equals to 0, there is a possibility that it could be a point of inflection, right? Correct? Because by doing the first derivative in this manner, you're only looking for stationary points, you're not looking for turning points. Correct? Okay, so I take back my words about not needing to find maximum minimum, okay? Because the question specifically say that it's turning points, okay? We need to verify whether it's a maximum or minimum, or verify if it's going to be a point of inflection or not. Okay, so to do that verification, we do a second derivative test. Okay, so we have negative sine x minus cosine x, and when it is pi over 4, we find that it is approximately this. Okay, so when x is pi over 4, this is going to be a maximum, while this is a minimum. think this will then answer the question properly. So if the question were to say find the coordinates of stationary points alone, then you need not go and verify. But since it says turning points, then we should go and verify. Any questions so far? Okay, next one we want to find the range of value of x for which fx itself is increasing. Okay, fx is increasing. What is the condition for increasing function? Sorry, what's that? What must be the condition for your function to be increasing? Yeah? Your first derivative must be more than 0, right? Okay, so our first derivative, we got it here already. So we need this to be more than 0 in order to determine the range of values of x. Okay, so let me just erase this part. Okay, so our aim is to find range of values of x. So cosine x minus sine x more than 0. Okay? And then we got a problem, how to find the value of x. Any recommendations? Yep. Move sine x over. Divide. Divide by what? How do you get that? Put sine the other side. Like that. Then divide by sine x. Divide by cosine x. So tangent x is less than 1. Any disagreements? Tangent x less than 1. So your x is, your range of values of x is what's the range of value of x? Okay, we cannot do this, yeah? Alright, we cannot do this. Okay. So, let me explain why we cannot do this. Okay, you cannot just take your sine x over to the other side and then you happily divide by cosine x. Reason is because we are looking at an inequality, we are not looking at an equality. Okay, so when we actually want to divide things, okay, in an inequality, we can only divide numbers, alright, numbers that we are familiar with, decimal, fraction, negative integers, all that we can do it. Okay, of course we cannot divide by 0 also. We cannot divide by a function, okay, cosine x, because cosine x is unknown, right? So therefore, we cannot go through this process. Then what is the process that we need to go through? We need to go back to our graphs, okay? So we must sketch out the graph and look at the graph and determine what is the values of x. Okay, it is just like when we do our quadratic inequalities, okay, whereby we fall back on the graph itself to determine when is it less than 0 or when is it more than 0. Okay, so going back to this, there was nothing wrong by bringing your sine x to the other side. Essentially, when we write it in this manner, we are trying to get the idea that we want the sine graph to be lesser than cosine graph. Or we can see as cosine graph being more than sine graph. So that's how we interpret this inequality. Okay, so this is one idea that you could get. So drawing the graph, I'm sure probably Many of you forgot already. Okay, cosine graph, what shape? Cosine graph is this shape. Period of cosine graph is, anybody? Period of cosine graph? 360, good. But since we are looking at radian, let's go for 2 pi. So this is pi over 2, and then 3 pi over 2. So this is your cosine graph. Then we have our sine graph. Sine graph looks like this. Okay, sorry, the height should be the same. Okay, so this is your sine graph. Sine graph has same period 2 pi, then pi over 2, 3 pi over 2. Okay, all our quadrants. Okay, so far? Then now, going back to inequality, we want the case where we want the values of x, where cosine is more than sine. That means that we want the blue graph to be above the red graph. Alright? And we see that it happens only when in this segment, okay, this is the range of values of x, then it continues to become below the sine graph, and then from this part onwards to here 2 pi, our cosine graph is above the sine graph. Got it? Okay, so what is this number here and what is this number here? We have to go and solve. Okay? How to solve? Right? This point is the intersection between the sine graph and the cosine graph. Likewise, this point is intersection between sine and cosine. So we solve for the intersection by making it equal. And when it's equal, we know how to solve. We can divide by cosine. So this is 1 equals to tangent x. Okay, and then x is equals, or rather the basic angle is 45 degrees. Or pi over 4, since we're looking at radian. Okay, so we only want 2 points. This is the first one, first intersection. This is the second intersection. Okay, if we have more intersection, then we need to keep running on in our values of x. So since we only want the first two, first quadrant, pi over 4, and third quadrant will be pi plus pi over 4. Okay? Did we have to actually go through this idea, do this working? It is not necessary if you realize that you did the same thing when finding the turning point. We did this same set of working in part I already. Right? But just in case, okay, your question is not phrased in this manner, then you have to do this. Okay? So that means that this point here is pi over 4. This point here is 5 pi over 4. So the range of values of x will be between 0 to pi over 4, or else from 5 pi over 4 all the way to 2 pi. Okay? So that's the answer. These two inequalities must be present to answer part 2. Okay? Next, part 3. fx is decreasing. Same set of working, but we don't need to go through the rigorous step anymore because we have already done the base. Okay, so we are looking at f prime x to be less than 0. Since it's decreasing, that essentially means cosine x minus sine x less than 0. Or in other words, cosine x to be lesser than sine x. No need to redraw the graph, we have the graph already. We want the cosine graph to be below the sine graph. That means that we are now looking at this segment here, okay, all the way to this intersection. Okay, that's the only one. We're looking at this area here. So answer will be pi over 2 all the way to 5 pi over 4. Sorry? Pi over 4. Oh yeah, sorry, I read wrong. Thank you. Okay? Questions? Oh, sorry. So minor edit. Forgot to put in equal sign here and equal sign here. Because it includes, right? 0 itself and includes 2 pi. Down here inclusive. Okay. And the other side not inclusive. Okay, there's no equal sign for the others. Reason being, this is an intersection point. That is where sin x is equal to cosine x. Okay, there's no one that's above the other. Okay, cosine x is not above sin x, neither is sin x above cosine x. So this is an equal part, intersection part. That's why it is a strict inequality sign. Okay. Questions? So with that, okay, my chapter 15.1, we have gone through the necessary questions already. So for this homework, on week due by next Monday, okay? Okay, you might find it a challenge, okay, to do some of the problem sum question. Okay, so you may want to fall back onto your the chapters that we learned in chapter 14, 13, and 14 and 13. Okay, so that's where the concepts come in. All right. Let's move on to 15.2. Differentiation of exponentials. Can I move on? Erase. Okay. Okay, when it comes to differentiation of exponential functions, I hope that you will be very happy with how the differentiation turns out. Okay, the differentiation remains exactly the same. Okay, so if I were to differentiate an exponential function ex, it remains the same as ex. Okay, but of course, if I were to differentiate e to the power of ax, where a is a number, it does remain the same as e to the power of ax, but we need to differentiate ax itself, which is a, so we need to times the a. Okay? Even if b plus a b, which is another constant number, it will still be a to the power of e to the power a times e to the power of ax plus b. Okay? So This is differentiation of ax, differentiation of ax plus b. Okay? So it can't get any simpler than this. In try 5, we want to differentiate all this. Your product rule, quotient rule all comes in the same way. So if I were to differentiate x plus 1 times e to the power of x, product rule applies, keep the left, differentiate the right, which is still ex, plus keep the right, differentiate the left, which is going to be 1. Simplify it. Okay, keep it factorized, e to the power of x times x to the power of x plus 2. If I were to differentiate 2e to the power of x over x, we will use quotient rule, okay, or if you like to bring it up to become a product rule, that's perfectly fine as well. But in quotient rule, we will keep the bottom, differentiate the top, okay, then after that minus away, keep the top, differentiate the bottom over x squared. And then part C, differentiate e to the power of x minus 1 squared. Your chain rule applies. Bring down the power, power minus 1. Differentiate inside. Ex maintains, minus 1 becomes 0. You may choose to write it in this manner. Just be very careful. Sometimes when you write powers, right, okay, involving e to the power of x, your minus 1, please don't write it slanted, and then after that, your minus 1 suddenly become the power, and then you will change the whole meaning of the question. Okay, that is something that can happen a lot of times. Right, so be very careful and mindful of how you write. So what if we want to introduce some Trigo or something looking more complicated algebra into our exponential? To differentiate differentiate our e to the power of 2x plus 1, what do you think we will get? See, what do you think you will get? Sorry, say again. 2e to the power of 2x plus 1. Anything else? No. Okay, great. So that's a differentiation of e to the power of 2x plus 1. What about e to the power of square root x? What would the differentiation be? Amanda, what do you think? Shall I maybe write it in this manner for you? What would it be? For exponential, always keep it the same way. Then after we multiply by the differentiation of the powers. E to the power x to the power half. Multiply by what's the differentiation of x to the power half? Half x. Anything else? Negative half. Okay. Anything else? Do we all agree with this? Okay. So differentiation of e to the power x to the power of half. Keep the whole exponential function. Differentiate your x to the power of half. That will mean that you bring down the power minus 1, so negative half. Okay. So we get that. Let's simplify this answer. We would be having 2 square root x over e square root x over 2 square root x. Okay? Then last one, just write it here. Differentiate your e to the power of negative x cosine x. We do our product rule. Keep the exponential. Differentiate cosine plus keep the cosine. Differentiate the exponential. There is a negative x over here, so we need to multiply by negative 1 because that's the differentiation of negative x. Okay, then simplify our answer. Minus away. Okay, you can write it as negative sin x over e to the power x minus cosine x over e to the power x. Or in fact, you notice that the denominator is the same, so pull out the negative sign. Numerator will become sin x plus cosine x because we factorize out the negative. So a simplified answer will be this. Okay? Yep. Sorry? Around where? Outside. No need, because this one is in the center of the fraction. Unless you put it on top, then you need to put brackets like that. Yeah. But if you put in center of fraction, no need. Okay? Alright, we'll go for lunch break. Right? Now, right? Okay, 2 more continue with our exponential. Okay, just to give you a bit of heads up, okay, I went to look at our lesson sequencing and all that. Okay, our aim for your mid-year exam is to end at chapter 16, right? Okay, so we're now at chapter 15 midway only. Okay, we still have to learn how to differentiate logarithm functions. That's after this one. Okay, so I am foreseeing that we might actually finish chapter 16 by week 3 of week 3 or 4. Sorry, not week 3. So that's week 3 so far. By about week 4. Okay, and that leaves us about 1 week before your mid-year exam in week 6. Okay, so week 5 is going to be mainly revision. So because of the shortage of time and it's an odd week, right, where we only have 2 periods with each other, okay, I will probably only afford to do 1 paper. Okay, so there's a lot of your hard work.